Good day to all. This is Kenneth Frias, and our lesson for today is about heat engine and electricity distribution. What is a heat engine? It is a structure that converts heat energy into two mechanical energy. So it's a structure that converts heat energy into mechanical energy. It has two types. First, there's the internal combustion engine. An example is this image on the left, which is the car engine, this one. And the next is the external combustion engine. So the example given is this steam engine that is used in a locomotive. Two laws of thermodynamics are observed in heat engines. First, energy is not created or destroyed, but transformed into different forms, and that is the law of conservation of energy. And then the second is, as energy is transformed or transferred from one system to another, some of it becomes unusable in the form of heat, and that has something to do with the increasing entropy in a system or the randomness in a system. First, let's learn more about the internal combustion engine, the one that that typically we see on inside the car engines. So when we talk about internal combustion engine, the heat source is found inside the engine piston. In this illustration, this one is the piston there, the one that is going up and down. And then as these pistons are going up and down, it could be divided into 4 actions or 4 strokes. First is the intake stroke, that is a downward motion. Then there's the compression stroke, it's going up, the piston is going up. Then there's the power stroke, where the piston goes down again. And then there's the exhaust stroke, or the piston goes up. So it's an alternate of going down and going up. Now, first, there's the intake stroke. So what happens here is that the intake valve opens. So this one is the intake valve. So there are 2 valves here. So one of the valves opens. And then what happens next is that the fuel and air mixture is sprayed inside the piston. So there's a mixture of fuel and air. There's a fine spray that will go inside the piston, the chamber here in the cylinder. And then that's the time when the piston goes down. So that is the intake stroke. For the next, after the intake stroke, there's the compression stroke. What happens there is that the intake valve closes. That means both valves are closed. Then the piston moves up. What happens is that when the piston moves up, as you can see here, the fuel and the air mixture is compressed. And since this is a gaseous mixture, it increases the temperature based on the gas law. After that, there is the power stroke. What happens in the power stroke is that when we're talking about if the engine is run by petrol or gasoline, there's a spark plug usually at this side. So this one is the spark plug. The spark plug ignites. So there's an electrical current that is being ignited there. And it's the one that causes the compressed fuel and air, which is already high in temperature, to combust. Okay, so combustion occurs. And take note that in this power stroke, both the valves are closed. Then, because of that combustion, it will force the piston to go down again. That's the power stroke. And you have to take note that spark plug is usually present in engines that are run by petrol or gasoline. But in the case of diesel engines, there is no spark plug because the fuel that they use, the diesel fuel, when the compression happens, the compression is enough to ignite the fuel. But in this case, since we're dealing with the petrol or the gasoline fuel, there's a need for the spark plug. So the compression will just increase the temperature, and then the spark plug will ignite the fuel, and then combustion will occur. And that will force the piston to go down. Then after the combustion, there's the exhaust stroke. What happens there is that the exhaust valve, which is this one, it's the one that opens, and then the piston moves up, and then the products of the combustion reaction, which is these particles here, they go out of the cylinder through the exhaust valve. And if you're going to notice here, the animation here, the timing of the opening and the closing of the valve is regulated by this, the camshaft. Okay, so if we're going to combine all the strokes, the 4 strokes in an engine, whether it's diesel engine or gasoline engine, there's first the intake stroke. The intake stroke first, wherein the valve opens to spray in the mixture. So there's the intake stroke, and then there's the compression stroke. The valve goes, the piston goes up, compresses the air, and then there's the power stroke. Spark plug ignites, and then combustion takes place, and then there's the exhaust strokes. After the combustion, you'll notice that the exhaust gas or the waste materials will go out of the exhaust valve. And as a side note, as I said, the right timing of the opening and closing of the valves are regulated by the camshaft. These are the camshafts. So they make sure that the opening and closing of the valves are synchronized. They are in line with the action of the piston inside the cylinder. But in diesel engines, ignition occurs due to gas compression only. No spark plug is needed. Now for the external combustion engine, so from the term itself, the heat, so the heat source or the combustion occurs outside the piston. As you can see here on the example of a steam engine from the locomotive train, you notice that the steam is outside, and it's the one that feeds the steam here, goes inside the cylinder, and it pushes the piston. And you notice there's an alternate outlet. So whatever outlet is open, that's where the steam goes in, and it's the one that pushes the piston either going to the left or to the right, and it causes the turning of the wheel. Now this secondary fluid or the steam is the one that does the work in this external combustion engine. Now this steam is produced, of course, because you have to boil the water. So this is accomplished by, of course, burning fuel, okay, fossil fuel, usually in the form of coal. Now, another example of external combustion engine is the Stirling engine. So in this case, this type of engine, the pistons are driven by the following. It's the cyclic expansion and compression of air because of the differences in temperature. There. So some, like this one, is more on the temperature differential. Now on these two types here, there's the cyclic expansion and compression of air. So there are 3 types, the alpha, beta, and gamma. So this is the alpha, this is the beta Stirling engine, and this is the gamma Stirling engine. Now for the alpha, what you'll notice here, there are 2 pistons. So there's a piston here, then there's a piston here, and then the heat source is outside. So it hits the air, and then it pushes the piston and it turns the wheel here. And then there's an alternate, okay? And then also the heat is also driven to this side of the piston, which also drives the wheel. So there's the expansion and compression of air. So there's an alternate. Same with the beta. Here in the beta, notice this is the heat source. And then it pushes the piston, which also turns the wheel. So you'll notice this is an external combustion engine because the heat source is outside the engine, unlike the internal combustion engine. Now the gamma, this one, uses the temperature differential. So these are usually divided into two plates. The upper plate is the colder one, and then the lower is the hotter. So when you place your hand, so the heat or the thermal energy from the hand goes to the lower plate, and it increases the temperature of the gas inside, therefore pushing it. So there's a temperature differential. And of course, there's the displacer inside, which pushes the gases in different places. So there's an alternate expansion and compression of air. Same goes with the alpha and the beta types of the Stirling engine. Now, another example of an external heat engine is this power plant turbine. We know that the turbine is very important in power plants, okay, because this is attached to a generator, electrical generator. So power plant turbine, so in this case, they also use steam. So the heat source is also outside. So the steam turns the turbine blades, and it also turns the generator. So you can see here, the steam, which contains the heat energy, converts it into mechanical energy. So the turbine is the one that converts the heat into mechanical energy. And then the turbine turns the generator, which has magnets inside. And this converts the mechanical energy into electrical energy. Now, in the generator, which has magnets in it, the generator turns the magnets inside, which these rotating magnets induce electric current. So these magnets, there's also a conductor inside, which induces electric currents to the conductor, which increases the flow of electrons. Thus, this generates electric current. And this is the process where the mechanical energy is converted into electrical energy. Now, since power plants utilize turbines, which is a type of heat engine, external heat engine, and generators to generate electricity, how is electricity distributed to our communities? So from the power plant, which it's the one that it's a structure that generates large amounts of electricity, the electricity's voltage is increased further. So through a step-up transformer, so that it could be sent to transmission lines. Because the purpose of transmission lines is for the electric current to travel long distances. And this is supported by the transmission towers. And as you can see here, from the power plant, the electricity's voltage is increased to about 138,000 volts. So it's they increase the electromotive force. Okay. Then what happens next is from the transmission tower, which supports the transmission lines, the voltage is decreased as it reaches the substations. So this substation could be a distribution substation, or it would distribute the electricity to communities or to other substations. So there's a need for to decrease the voltage. So from 138,000 volts, decrease to about 13,000 volts in the substation. Then from the substation, distributes the electricity to, if it's a substation that's designated for community distribution, this 13,000 volts is distributed to the utility poles there. So this is the one that you see outside the streets in the community. So still large amount of volts. Then in this utility poles, you can see this structure. This is called transformer, another transformer. This is the one that further reduces or lowers the voltage to 120 volts, which is the amount of volts that is that can be used in the household. So in every utility poles, there's a designated transformer that could reduce the voltage of the electricity to 120 volts. And from that utility pole, there's what we call the service drop wire. So in every pole, there's another wire that will connect the utility pole to your house, our house. This one, this is the utility pole, and it's the one that will send the 120-volt electricity down to our homes, so that we can use it in powering our gadgets and other appliances in our houses. And as a summary of the pathway of this electricity distribution, so it's from the power plant here, whatever type of power plant, whether the source is geothermal or they say nuclear or coal powered, okay? They are the ones that drive the turbine inside the power plant, which drives the generator and converts this energy into electrical energy. Then it's sent to the transmission lines. With it increases the voltage so that it can be sent to longer distances, and then it reaches the substations, this one, where the voltage will be decreased, and then to the community where there are utility poles. So in this case, the voltage is decreased through a transformer, and then from the utility poles, it is further decreased to 120 volts. And then it reaches your home through the service drop wire there. So this is the summary of the distribution of electricity from the power plant to the individual houses in the community. Now, as a summary of this lesson, remember that heat engine is a structure or is a device that has the capability to convert heat energy into mechanical energy. There are two major types of heat engines. There's the internal combustion engine, which is typically used in vehicles. And then there's the external heat engine. And there's also the external combustion engine in the form of turbine, okay? And also the locomotive, so the old school type of engine that is used in the early transportation. And of course, it's also used in turning the turbine and generators, which is found in power plants. And these power plants utilize this engine to generate electricity. Now, electricity is very important in our lives today because it is the one that powers our gadgets and our appliances. And this has a major contribution in the development of the society, of the community. Now, in order for this electricity to be distributed efficiently, it follows the following basic path. From the power plant, where the majority of the electricity is produced, it goes to the transmission lines and then to the substation. So while traveling through these different areas here, through these different entities here, or through these different facilities, remember that the voltage of the electricity is increased and decreased accordingly until it reaches the community, the utility poles, and then there's the service drop wire that connects this 120 volts of electricity to our homes. And that will be all. And I hope you understand the lesson. And thank you very much.